To the moon has now become one of our most important goals. For this reason, in 2009, NASA sent two new spacecraft launched in tandem to the moon. They were the Lunar Reconnaissance Orbiter, or LRO, and the Lunar Crater Observation and Sensing Satellite, or LCROSS. The data sent back from these robotic voyagers are now helping us answer some of the most crucial questions about whether or not people will be able to survive on the moon for extended periods of time. LRO and LCROSS were the first in a series of new NASA missions to explore the moon in ways never before possible. Their purpose was to help us find safe landing sites, locate life-sustaining elements, understand the effects of the lunar radiation environment. After launching together, LRO separated from both the Centaur upper stage and the LCROSS spacecraft and followed its own prearranged course to the moon. It will continue orbiting over the lunar poles for up to 5 years. The remaining spacecraft, the LCROSS probe and the Centaur upper stage rocket, stayed together. They looped around the moon and the Earth for over 3 months in order to set up the perfect trajectory to crash into the moon near the lunar South Pole. The first steps in the next great age of space exploration have begun. LRO eventually settled into a low polar orbit, one which brought the satellite to within 30 miles of the lunar surface. It continues to chart the terrain as it goes, creating a comprehensive atlas of the moon's features and resources. Such detailed information will be essential in designing and building a future lunar station. LRO is also focusing on the selection of potential landing sites, as well as identifying chemical compositions and studying the effects that radiation will have on future inhabitants. The images received from LRO have over 10 times the detail of any previous orbiter. The resolution is so high that we've even been able to spot, also providing details about the early history of Earth and the solar system. LRO is testing new technologies. Probe, Lunar Prospector, detected large amounts of hydrogen at the moon's poles before crashing itself into a crater at the lunar South Pole. Using a much larger projectile, LCROSS's mission was to find out whether some of that hydrogen is locked away as frozen water. For over 3 months after launch, LCROSS acted as a shepherding satellite. It guided both itself and the Centaur booster rocket into just the right trajectory for a high-angle impact into a crater named Cabeus, near the moon's South Pole. Once the spacecraft lined up with the crater, the two then separated. As LCROSS watched, the Centaur became a 4,400-pound impactor spacecraft. Traveling at over 1.5 miles per second, the Centaur smashed into the moon. It blasted out a crater over half the size of an Olympic-sized swimming pool, nearly 100 feet in diameter and 16 feet deep. The impact blast ejected an 1,100-ton plume of lunar matter high above the surface of the moon. This cloud, over 9 miles tall, was visible from LRO. LCROSS itself was packed with instruments that not only gave us a near real-time look at the collision of the Centaur, but also analyzed the impact plume